Okay, hello guys. So this is Rishikesh Patade, and we'll be doing a quick sort here and implementing it. Firstly, we'll start with what's quicksort. So quicksort is a basic sorting algorithm. It is widely used because it is very useful in terms of time complexity. It has an average time complexity of n log n. So, and the worst time complexity that it has is O of n square, but that's not the point here. But the average time complexity is the one which we consider because the thing is, it has a time complexity of n log n and also a space complexity of almost null. So the thing is, what we do in here is apply a divide and conquer method. We take small arrays. So we divide the array, we keep dividing the array in small parts, and we keep sorting it. We do that by taking a reference value that we call as a pivot, and usko, according to that, we'll be on the left side of the pivot, we'll be keeping the less than pivot values, and on the right side, we'll be keeping the greater than pivot values. And essentially, ऐसा करते करते we will be sorting it finally. Okay, so let's get started with it. I'm gonna show you direct how it works. So here we are gonna take 3 as the pivot. Okay. What we do here essentially, it's not that the value is 3, that's why I'm taking it as a pivot. The thing is, 3 is the first element in my array, and that's the only sole reason why I'm taking it as the array. Matlab, as the array's pivot. Okay. So 3 will be the pivot for 2, 5, 6, and 1. These are the remaining values. So what I'm going to do is, this is the pivot. I'll just write p here. This is counter I mean pointer I rather. Then this is j. Okay. So what we're going to do is, wherever j points now, we are going to compare j with p, and if j is less than p, then we will swap the value at j and I. So this is how the whole thing will be going on. After we have swapped with the thing with I, matlab j with I will be incremented by 1, and no matter what, like after every iteration, like after every encounter of each position, j will be incremented. Like for now, let's get started. You get what I mean after seeing this example. We'll be running it as in logic wise. So first, we start with 4. 4 is not less than 3, so there won't be any swaps or anything. So now we'll just advance to the next value, 2. 2 is less than 3. So what's gonna happen is 4 and 2 are gonna get swapped. Okay, so this is 4 and this is 2. And like I said, I will be incremented every time it's swapped. Now j will go to the fifth, matlab number 5, and it will see that it's not less than 3, so no effects will take place. 6, likewise 6 के साथ भी वही होगा. So the same happens with 6, and we advance to 1, and 1 is less than 3. So what's going to happen is if I and j positions, whatever the values are, they are going to get swapped. So this becomes 4, and this becomes 1, and I is incremented by 1 as always. So since j has come to an end, there's nothing to do more. So this is it for our current sorting. And what we have encountered here is these numbers 2 and 1 are less than 3, and that is 3, that is the pivot, and the other numbers which are greater than 3 are supposedly at this side. So what we are going to do is that the last swapped element, we are going to exchange those values with the pivot. So last one was 1. Last swapped element was 1, and we are going to exchange 1 with 3. We are going to do this, and we get it at this. Okay, let's remove this. So now what has happened here is, uh, at the left side of 3, there are all elements which are less than 3, and on the right side, there are all elements which are greater than 3. So after we have done this, we are going to call quicksort on the left side and the right side of 3. So we will be taking 1 and 2, and we'll be calling quicksort on it. There won't be any changes taking place in this thing because essentially 1 and 2 are already sorted. But let's see what happens exactly. So 1 and 2, p is like I said, the first element is set as the pivot, and the second element we just initialize this particular ing. So we compare j with p and just see if it's greater than or not. So since less than or not, so since one say greater here two, there won't be any particular swaps taking place. So what's gonna happen is that j is gonna get swapped with. I mean, j has come to an end, so nothing really happens here. And now what happens is what I said earlier, that the element which was last swapped and the one pivot one will be swapped. So in this case, the earlier position to is p itself. So the pivot will be swapped with itself, and it doesn't make any change in the particular set array. So what happens is now one is the pivot final, and two is the number which is greater than the pivot, and we have to call quicksort on it again. The thing is, since it's a singular value, there won't be any particular thing taking place on it. Like there won't be any change taking place since it's a single value. What can happen, right? So this is it for the left side. That's why one and one. This whole thing is now sorted. Okay. Now what remains is this one. So for this 5, 6, and 4, what happens is p is 5 and I is here, and this is j. So now we compare j with p. So it comes out that j is not less than p. Like we can see, it's 6, so it's not less than p. And now we next move on to the next value, which is 4, and 4 is definitely less than p. So now what happens is that I and j swap. So that results into this. Okay, and I is as always incremented by 1, but now, like I said earlier, since j has come to an end, what we are going to do is that the earlier place to I, that is the last element swapped, will be swapped with the pivot, and because of that, this particular thing becomes 5 and this becomes 4, right? So this becomes your array. Now this subarray which exists here, it has pivot as 5, and the left side will be again put for quick sorting, and the right side will be also put for quick sorting. But the thing here is that both are singular. Like there is only 4 on the left side and only 6 on the right side. So essentially the quick sort takes place and it realizes that only one element and there can be no changes in this particular thing. So it returns, and finally the array is sorted. So this becomes this. Okay, so it is now finally sorted. 1, 2, 3, 4, 5, and 6. So I hope you understood what exactly happened here. If you haven't understood, I hope you understand why the implementation that we are going to do here. The implementation will be very simple. It will be exactly what I said, but just in C++ language. So now I'm just gonna make a function quicksort here. I'm gonna pass an array in this. Passing the array is not essential here. I'm just we can even pass a pointer, like the first thing that there is, like this. The first element of the array, uska pointer we can pass directly. That's not an issue. So the other thing that we'll be passing is the left bound. That is the what will be the left bound of the subarray that we'll be sorting, right? So also there will be right bound, just like the left bound. It will indicate what is the particular right bound for the subarray. So now I'm gonna write simple code here, which will be I'll be taking in number of values that we'll be taking in. That is, for this case it was 6. So that's what's gonna happen here too. Now I'm also gonna initialize an array named VRR of size n, because the numbers are gonna be n. So that's why I'm initializing only to n. And what I'm gonna do is I'm gonna call my macros here. So I have I have defined a small function kind of thing, which helps me in taking in the values and putting them into the particular array that I have told it to put it in. So this gets me values and loads it into the array ARR, and I call quicksort on this ARR array, and what's gonna happen is that 0 comma n minus 1, so this will be it. Okay, so the thing is that I have written here 0 and n minus 1 such that they represent left and right, that is the left bound and the right bound. So because of this we are able to identify what subarray we are currently sorting. So that's it for the quick sort parenthesis में जो parameters डालने, that's it for that. Then further after sorting we'll be just putting out the array, and I have defined a macro for that right here on line number 5, and it will be outputting a whole of the array. So what I'm going to do is, the main function is over now. The other things that we have to do is that define the position of the pivot after a particular quicksort is performed. So on a particular array, when a subarray, when I perform a quicksort, the pivot is actually the only one which is absolutely sorted. So here the pivot location is necessary so that we can identify what subarray we have to particularly quicksort furthermore. So I'm gonna just use the earlier parameters that I use for the quicksort one, since they will be needed. Now, so I'll be just defining the pivot here. Pivot equal to array left. So what this does is that it initializes a variable named pivot, which has an int type data, and the thing here is that I have initialized it and given the first one. That is, in this case, if I have particularly sorting this array, so I have given 3 as the pivot. Like first element that is leftmost is the first one, right? So this 3 will be set as the pivot for this particular array. So for any particular array, the first element will be set as pivot. Now further, I'll be using iterate, a variable named iterate, which will be helping us in swapping things. So it will be performing the role of I that here we use. Like it was a thing that 3 wait 3 4 2 5 6 and 1 was there. This was P, this was I, this was J, right? So the iterate is gonna be I. This and this are same essentially. Now I'm just converting it to C++ language. So left plus 1. So it's going to start from left plus 1, that is fourth in this case. So now let's start the iteration thing. We'll be iterating, that is here curr named variable will be iterating just like J was iterating through the whole of the subarray. So it will do so until it meets the end, uh, and I'll just put the increment counter here. So now I have to check every time that I if the current value is less than pivot or not. If it is less than pivot, then we are gonna swap it, or else we won't be doing anything else, right? So I have defined another here, right? On line number 6, I have defined another macro which will be helping us in swapping the two positions. So err current and comma err iterate, and that will be it for the swapping. And now, like I said, we incremented the i's value here. The I value we used to increment, right? So that we go to the next one and we store our next swap there. So I'm writing it here. I would have simply written the plus plus unary operator here too, but this just seems appropriate. Like the code becomes smaller, but the thing is that it should be readable to a new beginner or any person who is reading it for the first time and not well experienced in reading codes. So that's that. So finally, after the loop, whole of the loop is over, I mentioned that the last position which was swapped will be swapped with P, that is the pivot. Like in this case, I think the last position was. mm Wait, let's do it. Okay, so this becomes for J. J goes here. J. Okay, J goes here, and I think I is here, 1 and 4, like this. It happens like this. Okay, so after swap is done, it goes to 5, right? Okay, so like I said, it will be swapping the this 1 and 2, so that 3 comes in its appropriate place, and all the less than and greater than are sided left and right respectively to the left and right side of the pivot, that is 3 in this case. So swap and ARR of left, then ARR of iterate -1, iterate -1, since -1 will just take it back, since we are iterating after every swap we are just incrementing the value, right? So it will be one step ahead from the position where we want it to actually be. So instead, that's why I'm doing iterate -1 for the sole purpose, and I'll also be returning iterate -1. I did this because I wanted the position of pivot in that subarray. So now we are going to see why we actually needed the position of the pivot. So what I'm going to do is just simply copy this. Okay. So I'm going to check first of all if the left is greater than or equal to right, and if it is, then it will just return. So this ensures that if a single thing is remaining, like we saw in the 1-2 subarray or the 4-5-6 subarray, like we saw it, right? There was 4, 5, and 6 written, and to the left of 5 there is 4, and to the right of 5 is 6, and both are singular. That's why they would just return, because there is nothing that they can do. So this is essentially that thing returning, and if it is not such a thing, like if left is not greater than or equal to right, then it will just continue to the further program. So the mid part. So this is essentially the position of the pivot, and it will be partition of the given subarray, that is ER comma left comma right. Okay, and then we will be performing quick sort on the left and right side of the pivot that we have acquired, right? This is essentially, we are just breaking it into small parts, and again, this is the inside function that we are inside subarray that we are performing the quick sort operation on. So ARR comma left comma mid -1, since the position like one position earlier from the pivot. That's what this indicates. Okay, then quick sort AR, okay, ARR mid +1, so that it's one step ahead of the pivot's location. And what? Right. So this will be it. This will essentially be sorting the whole array. So I think it's time to try and execute this code. I'll just compile it. Mm, okay. It's taking time, I guess, for the first compilation. Okay, it works fine. So now we are gonna try it. Yeah, this. Yep, it totally works fine. Just for sake of like reassurance, I'll just do it once more. Undo 3, 4, 5, 6. Okay. Yep, works fine, totally. So that's it. Now we have successfully implemented the whole quick sorting method, and I hope you understood what we had to do here and what exactly we did. So if you have any other questions or any other doubts, please go ahead, comment on a video. Please like, share, and subscribe. We are also on Telegram and Instagram. Please look at the description. You will surely find our account links there. Yes. So thank you. See you next time.